welcome back. Today we join a massive-scale construction operation, starting with a raw, uneven plot of land. Before a foundation can bear weight, the topsoil and organic matter must be stripped away. A concrete base poured directly onto root systems will eventually crack as the vegetation decays and the earth settles.
With the site cleared, precast concrete beams are craned onto the foundation pads. Using prefabricated structural members drastically accelerates the early framing phase. The circular voids cast into these beams aren't just for weight reduction. They create permanent raceways for future plumbing and electrical lines. Mechanical fasteners secure the structural nodes, but metal anchored directly to concrete requires isolation. Expanding foam is injected into the gaps to prevent moisture intrusion, which could otherwise corrode the internal steel anchors. Once the foam cures, a final layer of mortar seals the connection flush. This two-part weatherproofing protects the foundation's load-bearing integrity from rust and freeze-thaw cycles.
9개.
As the floor slab is poured, trapped air becomes the primary enemy of structural strength. An immersion vibrator is submerged into the wet mix, emitting high-frequency oscillations that force air bubbles to the surface. Without this step, hidden voids would create weak points in the cured concrete. Following the vibration phase, the surface is leveled with a hand trowel. The smooth finish isn't purely aesthetic. It prevents standing water from pooling on the floor once the facility is operational.
하나 좀 걸었어. 됐어.
Moving upward, precast floor panels are locked into the grid. A specialized grout pump forces a high-strength cementitious slurry into the joints between the panels and the support beams. This process fuses the individual panels, transferring live loads evenly across the structural grid. Any remaining thermal bridges in the steel framing are then sealed with polyurethane foam. In large-scale enclosures, controlling internal climate starts with eliminating draft points at the perimeter.
내리고 스톱 시간요. 예.
Final subfloor requires massive volume. Workers use wide bull floats to push down the coarse aggregate and bring a thin layer of cement paste to the surface. This creates a dense, durable top layer capable of withstanding heavy machinery. Timing is critical during a pour of this magnitude. The crew must screed and float the entire expanse before the concrete begins its chemical hydration and stiffens. With the concrete cured, the superstructure assembly begins. Abrasive cutting cleanly sever the steel beams, but leave raw edges vulnerable to oxidation. To prevent this, protective sealants are immediately applied to the exposed seam. Vertical columns are hoisted into place and tacked to the foundation beam. The welder ensures perfect plumb alignment much before running a full fusion beam, permanently securing the steel skeleton to the earth. The arched framework is now clad in heavy-duty polyethylene sheeting. The curved profile sheds drain efficiently while maximizing interior volume. At the base, insulated wall panels are bolted to the perimeter, creating a thermal barrier that prevents ground frost from creeping inside. Securing the plastic skin requires continuous tension. The sheeting is locked into an extruded metal channel along the foundation line. This interlocking track system distributes wind loads across the entire perimeter, preventing localized tearing that would occur with standard point fasteners. A final layer of black shade netting is pulled taut over the plastic canopy. Direct sunlight in a sealed greenhouse will quickly elevate internal temperatures to lethal levels. The mesh intercepts solar radiation before it hits the plastic, drastically reducing the cooling load on the ventilation system. Inside, industrial exhaust fans and pressure sensors maintain strict environmental control. The structure is now a fully calibrated machine ready to sustain life regardless of the weather outside. Construction takes many forms, and not all structures are permanent. Miles away, an empty stadium awaits a massive, temporary transformation. The engineering challenges here shift from agriculture to high-capacity entertainment. Before a single piece of staging can be built, the delicate stadium turf must be protected. Heavy equipment tires and tons of static weight would quickly destroy the natural grass beneath. The logistical operation requires staging hundreds of heavy transit cases on the perimeter before the central build can safely begin. A protective subfloor is laid down across the pitch, distributing the concentrated loads of the stage components. The crew begins framing a massive circular platform. Wood is chosen here for its acoustic deadening properties and rapid assembly speed. Metal decking would reverberate underfoot and interfere with broadcast audio. Simultaneously, vertical scaffolding towers are erected along the flanks. These trusses will bear the extreme weight of dynamic lighting rigs and LED video walls. With the primary stage skeleton locked in, connecting arteries are built. Temporary walkways are carpeted in green turf panels, blending the artificial paths into the stadium's natural aesthetic. Metal guardrails define the flow of traffic, ensuring crowd safety during a chaotic live broadcast. The festival infrastructure is vast, requiring precise coordination to map a temporary city inside an existing arena. The final lighting pylons are bolted together and hoisted upright. These towers provide critical front-fill illumination for the broadcast cameras. As the system boots up, the digital displays undergo live fire testing. The hardware is ready for the arrivals. Across the city, a secondary venue undergoes its own rapid transformation. The red carpet installation demands absolute precision. Any wrinkle or seam can become a tripping hazard under the glare of international media. Double-sided adhesive secures the fabric directly to the hardscape. Outside, structural crews build an immense entry arch using modular steel scaffolding. Unlike permanent architecture, these temporary rigs rely heavily on diagonal cross bracing and heavy ballast to resist wind shear. Riggers climb the grid in safety harnesses, pinning the upper joints together. an outdoor stage platform expands outward across the plaza. Modular stage decks lock together, resting on adjustable screw-jack legs. Plazas are intentionally sloped to shed rainwater, meaning the crew must individually level every single leg to create a perfectly flat stage surface. Small wooden blocks act as shims beneath the feet, preventing the metal bases from marring the decorative concrete below. A rigid wooden backdrop is framed and sheeted in plywood. This flat plane serves as the canvas for the event's visual branding. Plywood seams are meticulously flushed, so it won't telegraph through the vinyl graphics. Finally, a large format graphic film is applied using a squeegee to force out trapped air bubbles. The adhesion must be flawless to withstand outdoor humidity and wind without peeling. The rigging continues long into the night. Working at height in the dark introduces immense logistical friction, but strict event deadlines leave no margin for delay. Every connection point is double-checked under temporary work lights. Structural failure is not an option. The payoff is a few hours of flawless spectacle, resting entirely on weeks of hidden labor. The scaffolding vanishes under the glare of the lights, operating exactly as designed. In the end, temporary structures and permanent architecture share the same truth. A building is only as strong as its foundation.